Section 10.3, define and use probability. Well, the definition of probability is how likely is an event to happen? Is it going to be probable that it won't happen, or probably that it will happen? And we're going to set these up as fractions. And if you look at a continuum, if the fraction is closer to 0, then it's most likely that it will not happen. But as that fraction gets closer and closer to 1, then it's more certain that that event will happen. So a probability of 1 means that it for sure will happen. It's certain that this will happen. So if I flip a coin and say, what's the probability that I'm going to get a heads or a tails? Well, of course, it's every time it's going to happen. All right, so in order to make up that fraction, here's what we're going to do. We're going to put the number of favorable outcomes over the number of all the outcomes possible. So if I've got a deck of cards and I want to know what's the probability that I'm going to draw an 8 at random from this deck of cards. Well, the number of favorable outcomes is I need to draw an 8. And if you know a deck of cards, you know that there's 4 8s in the deck. You've one for each of the suits. So you've got four possible favorable outcomes out of how many outcomes are in the whole deck? Well, there's 52 cards in the whole deck. So 4 out of 52 is the probability that you're going to draw an 8 just at random. And then you would, just like a fraction, you're going to reduce that down. So that's going to be a 1 out of 13, 1 out of 13 chance that you're going to draw an 8. Okay, well, what if you want to know what's the probability that you will draw a red king? You can do that quick on your paper. You already know, right? So you know there are 2 red kings, one for diamonds and one for hearts. So 2 red kings in the deck. So you've got 2 out of that same deck of 52 55. I say 52, I write 55. That's just to keep you guessing. All right. And so if you divide that, you know that there is then a 1 out of 26 chance that you're going to draw a red king. All right, so now what if we say we can use our information or what we know about permutations and that principle of multiplication and of counting in order to find out sometimes how many outcomes do we have. So what we're going to do is this. If we've got 5 new, we're a company now, and we've got 5 new cereals that we've produced, and we're going to introduce them over the year. What is the probability that I'm going to introduce those cereals in the order of their price? All right. So what we want is we want the number of favorable outcomes over the number of all of the outcomes. So the number of favorable outcomes is, if I'm going to present them in the order of price, there's only one way that could be, right? There's only one way that they would be in the correct order. So that's going to be one option out of how many favorable outcomes are there? Well, if you remember, if there are 5 new cereals, if the order matters, which it does, if we're going to do it in a certain order, then we're going to use that multiplication principle. And if I choose 1, it's 5, and then I choose 1 away, and now there's 4, and now there's 3. Remember that? And so this is going to be 5 factorial. So 5 times 4 times 3 times 2 times 1. So that's how many options there are possible, and only one of those is going to be the one I want. So when you take 5 factorial, that's 120. So 1 out of 120 is the probability that I'm going to present it in that specific order, and then you can divide that and say that's roughly equal to 0.0083. All right. What is the probability that the first cereal that I present is the multigrain cereal? Well, the number of favorable outcomes out of the number of all the outcomes. Well, in this case, if the first one is multigrain, there's only one way that the first one can be multigrain. So the number of favorable outcomes is just 1. The number of outcomes altogether is, well, I want to know what the first one is. I don't care what all of them are. I just want the first one. So the possible number of first cereals is 5. There are 5 different options, so the probability is just 1 out of 5, or 0.2 in this case. So you can leave it the fraction or change it to the decimal either way. Okay, now that's probability. And you may have already done that before. What about the odds? You've heard people say, oh, they're going to Vegas, and what are the odds, and odds against, and odds in favor of. The difference is this: when you're figuring probability, you're comparing it to the total. When you're figuring odds, you're comparing to the other side. Okay, so the odds in favor of something take the number of favorable outcomes and they compare it to the number of unfavorable outcomes. So the ways that you can win compared to the ways you can lose. All right. The odds against you are exactly the opposite, or the reciprocal. So the odds against you are the number of unfavorable ways to the number of favorable ways. And now the difference is, in this case, it's not necessarily going to be just a number between 0 and 1 now. All right, so if I'm rolling a die, it's just a regular 6-sided die, what are the odds in favor of a 6? So now remember, this is comparing the number of ways you can win to the number of ways you can lose. So you have to decide, well, how is it that I'm going to win? Because it's in favor. I'm going to win if I get a 6. So there's only one way that I can win. And actually we can set it up this way. One way that I can win. And if there's 6 possible ways and one way I can win, there's 5 ways I can lose. So we've got 1 to 5 is our odds. Okay, so the odds in favor of rolling a 6 are 1 to 5. The odds against rolling a number above a 4. Now this gets a little bit trickier simply because when you go against, now you're dealing with negatives and you're getting all confused. So it's okay, don't get confused. So a number above a 4 is a 5 or a 6. So there's two possible ways you can win, right? So, but if you want the odds against, then the ways you can win go against, or go on the bottom, all right? So the ways you can lose are anything that's 4 or below. So 1, 2, 3, or 4. So there's 4 ways that you can lose. So now the odds are 4 to 2. It's 4 to 2 against you in this case. So then you're going to reduce that down to 2 to 1. Your odds are 2 to 1 against you. Okay, so the only difference is which number do you put on top. You're going to use the same numbers because you're comparing winning to losing or losing to winning. Okay, all right. Let's see the next thing. So there's a lot of quick different things in this lesson. The next quick thing is experimental probability. So experimental probability, all of the probability that we've dealt with so far has been theoretically. If you were to do 1,000, roll that die 1,000 times, this is theoretically, this is what you would get. So experimental probability takes actual data, actual information. And so in this case, we had a blood drive, and of these people that came in, this is the record of their blood types. So I had 22 people come in with O, 21 with A, 5 with B, and 2 with AB. So I want to know, if I just reach into that fridge and pull out a packet of blood, what's the probability that I'm going to pull out a type O? Okay, so in order to find experimental probability, you're going to take the number of favorable outcomes out of all of the trials, all of exactly what you have. This is not theoretical. This is exactly what you have in the refrigerator in this case. So the number of favorable outcomes in this case is the number of type O, and that's 22. And the number of trials is going to be all of them together. So 20, 40, 45, 46, 47, 48, 40. Oh, I thought I had 50. 5, 6, 7, 8, 9, 10. I do. Okay. 22 out of 50. So there's 22 vials of type O blood in the refrigerator. And so the chances that I just reach in and grab one, I've got a 22 out of 50. So reduce that down. And actually, you can just take the top divided by the bottom. And I had that, but I don't have it anymore. Where did it go? Oh, 0.44. All right. Okay, so you can either do 11 over 25 or 0.44. All right. Last thing. Is this the last thing? Oh, yes. Okay, one more thing. The last thing is geometric probability is what they're calling it. This is fun too. So in this case, we've got a dartboard. And I want to know if I'm throwing darts at this dartboard and I've got to get into the bullseye to get 10 points or into these corners to get a 0, and obviously we're going to get other points in the other circles, but we don't care about them right now. What am I more likely to get 10 points or am I more likely to get 0 points? We would guess that it would be more likely that we would get 0 points, but just looking at it, it's hard to tell because those corners are pretty small, and if I had drawn my circle to scale, it would be even more close. So what you're going to need to do in this case is, once again, we want the probability, so we're going to have the favorable over the total. So we've got to figure out, well, in this case, the favorable is an area. Okay, so the probability that we're going to get 10, the probability that we're going to get 10 is going to be the area that we get 10. So if you'll remember, the area of your circle is pi r squared. So we're going to do pi times the radius squared, and this says that the radius is 3, so 3 squared is 9. So 9 pi over the area of the entire thing, because anywhere on here is I can get points or 0 points anywhere on there. I want to hit the target. So the denominator then is 18 squared. So, and I think I did that already. So that, yes, so 18 squared is 324. So 9 pi over 324. So the probability is going to be roughly, oh, I'm going to move it down here, 0.0873 that you're going to get a 10. All right? So that's the probability that you'll get in that circle. Now, to get the probability of a 0, what we're going to do now is we're going to take the whole square and subtract out the circle to get these corners. So we're going to take 18 squared minus the large circle, which is 369, which is 9 squared pi over, no, not over, the whole thing. That's why I was confused. So the whole 18 inches squared minus the circle, which is 9 squared pi. And we're going to compare that to, so that's the favorable. The favorable is what's in here. And the whole thing is the 18 squared. So this is going to be 324 minus 81 pi over 324. And when you put that into your calculator, 324 minus 81 times pi divided by 324, you should get roughly, not exactly, 0.2146. And in this case, because this probability is larger, it is more likely that you will get 0 points. Surprise, surprise. The house always wins. Okay, so probability, odds, experimental probability, and geometric probability. It's all pretty much the same. You've got favorable over total, and if you've got odds, you've got favorable over unfavorable. I think you got it. See you soon.